What is bathymetry? Bathymetry is the science of measuring the depth of water in ocean, riverine, or lake environments. What kind of information can you get from bathymetry? Just like the surface of the land isn't always completely flat, the surface of the seafloor is full of various features like wreaths, ripples, mountainous ridges, deep canyons, and even shipwrecks. The bottom of the ocean is also very dynamic, meaning it's constantly changing. Bathymetry data provides scientists not only with a depth measurement but also a picture of what seafloor looks like. This can provide information about current and past conditions, what kind of substrate or the material that exists, and if there are any hazards for vessel navigation, among other things. How do you collect bathymetry data? Measuring water depth is not a new concept, but the way we do it has evolved over time. Historically, scientists would lower a lead weight attached to a rope over the side of a vessel to record the depth of water. Today, we use active sonar or sound navigation, and ranging a transducer emits a pulse of sound into the water column, which then bounces off the seafloor and then returns to the transducer just like an echo. The time it takes for the sound to travel through the water column is recorded and then calculated to provide a depth measurement. Scientists at the Ocean Sciences and Techniques primarily use two types of sonar transducers: single beam echo sounders and multi beam echo sounders. A single beam transducer repeatedly emits a single pulse of sound directly beneath the vessel, providing a single depth measurement along the travel track line. A multi beam transducer repeatedly emits hundreds of pulses of sound in a fan like fashion beneath the vessel, providing a large swath of depth measurements perpendicular to the vessel's track. How do you analyze or interpret what the symmetry data means after the survey vessels return to the dock? The data acquired is imported into a suite of special computer programs which allow scientists to analyze and interpret the data. These programs perform all the necessary calculations to assign each pulse of sound emitted from the transducer a depth measurement, or sounding. These soundings can represent the seafloor, a feature on or above the seafloor, or anything within the water column that may have blocked the sound from reaching the bottom. When all the soundings are put together, scientists can begin to see what the seafloor and associated environment looks like, many times with the use of high resolution multi beam data. The picture that is developed can even provide insight into habitat types, such as seagrass beds or reef structures. So, why is this work important? Our oceans, rivers, lakes, and waterways make up a large portion of the Earth's surface, but only a small portion has been mapped with enough detail to be useful. Vessels of all sizes need to know the water depth of the areas where they're navigating so that they can travel safely from port to port. Fisheries, industries, and fisheries managers need to know where specific habitats are located, which harbor certain species, and renewable energy sources, such as offshore wind infrastructure, need to ensure that they can establish systems safely and securely. Here at the OceanSciTech, we are using bathymetry data to map changes in the Mediterranean and the Red Sea open water and near-shore environments. This allows our scientists to better understand the seafloor and the associated environment, recognize changes, and provide predictions about how the seafloor, coastal environments, and coastal hazards may change in the future.